Welcome guys to another video in chemistry. Today we'll look at two questions, that is the manufacture of ammonia and part of organic chemistry. So let's go to question 1. So question 1 says nitrogen is used to manufacture ammonia as shown in the diagram. So we've got nitrogen, then X there, got Y, got catalyst, then we've got Z, atmosphere, then we've got ammonia. So they're saying name the process shown above. So the process that is used to manufacture ammonia. So the process that is used to manufacture ammonia is what we call the Haber process. So the Haber process is a process that is used to manufacture ammonia at industrial level. Now question B says state the substance represented by X. So you know that in the manufacture of ammonia we need two substances, that is hydrogen and nitrogen. So B, since we've got already nitrogen, so the only thing that we need is hydrogen. Next, C, which says like the conditions represented by Y and Z needed for the process. So Y is a temperature. You can say there is Y degrees Celsius there. So Y is a temperature, and we need the temperature of about 400 degrees Celsius. It's a very high temperature, and the reaction is highly exothermic. As a result, we need a catalyst. All right, that's why there's a catalyst there. So Z is the pressure, and the pressure can start from as low as 250 atmospheres. Okay, so it can start from as low as 60 atmospheres, 250 atmospheres, even 350 atmospheres you can have. Okay, so in that range you are able to have the pressure involved in the manufacture of ammonia. Well, pressure affects gases most of the times. So let's go to the right. So next question is name catalyst. So let's go to D. So it says name catalyst, the catalyst used, and write the main O. So the catalyst used in the reaction is iron, though they like saying finely divided iron catalyst. So that's a catalyst used in the manufacture of ammonia. Then the main O. So the main O from where the same catalyst, which is iron, is extracted from or is taken from is a hematite. It's hematite. All right. So that's the main O where the catalyst is taken from. Now E is saying construct a balanced chemical equation. Construct a balanced chemical equation for the reaction in the diagram. So we know that nitrogen as a gas is combining with hydrogen as a gas. This is a reversible reaction, forming ammonia as a gas. So we've got 2 nitrogen there, and we have 3 hydrogen atoms in front there. That's making 6. So we've got 2, 2, 6, 6. So the reaction is balanced. Then the use of ammonia, we are saying ammonia can be used for a lot of things, but here they just said one. So I'm going to mention a few. So I'll say manufacture of 1 organic fertilizers, then second, in the manufacture of explosives, Ammonia is also used in the manufacture of nitric acid. Ammonia is also used in the manufacture of detergents. So that's a summary process of how we can answer questions regarding ammonia extraction. Let's go to the second question. So question C3 says butene CH4 C4H8 is a compound belonging to alkene. Now we know that alkenes, they are part of the homologous series. Now they are saying, A, state the general formula for alkene. Alkenes have a general formula of CnH2n. So that's the formula, the general formula for all alkenes. Then B is saying, draw the displayed formula of the second member of the series. Now we know that the alkenes start from ethene, propene, butene, and so on as you go there. So the second is propene, of course. So we are going to draw propene, and propene has got 3 carbon atoms. So we are saying, so there's a double bond there.
Caleb.
Okay, so propene has got a double bond there and the 3 carbon atoms. So you know that if it has got 3 carbon atoms, it's going to have 6 hydrogen atoms. So there you need 1 as well, right? There you also need 1. So that's how you should do if you are doubting yourself. There you also need 1. There you also need 1. You count how many of you do you have? You've got 5. So the second carbon atom, which is linked to the first carbon atom by a double bond, doesn't have a base hydrogen atom, or it lacks 1. That's why they are unsaturated, because not all hydrogen atoms are used in the bonding with the carbon atoms. Then C says butene is prepared by cracking petroleum oils. Name the other method by which it can be prepared. Now the cracking process, it can be by catalytic or by fractional distillation. So the other way we can prepare butene is by dehydration. Now you know that during dehydration there's a loss of water molecule, like all those kind of stuff, which I shall explain later in the notes. Then D says butene 1En or butene, just the same, can be polymerized. Now the one which is here, it just shows that the double bond is on the first carbon atom. That's what it says. The one which is here, it shows that the double bond is on the first carbon atom, then linked to the second carbon atom. So now they are saying, name the type of polymerization it undergoes. So we know that these, when they are grouped together, they are monomers. When they are grouped together, they form one single compound or substance we call a polymer. So they are going to undergo what we call addition polymerization. Then draw and give the name of the polymer formed from butene 1. Show at least 3 repeating units. So let's see how we can draw a polymer of butene when 3 butene molecules combine together. So let's draw now the structure formed when 3 butene monomers combine. So we are saying, we know that butene has got 4 carbon atoms and it has got 8 hydrogen atoms. So we'll say butene 1, like that, plus another one plus another one. So we've got 3 repeating units, 1, 2, and 3. So when these guys combine, they're going to form a compound of this structure. I'm going to write it in a simplified way. So we are going to have, so the double bonds are going to break. The double bonds are going to break and they're going to form just a straight chain. So now we know that we've got it. 4, 4. So in the polymer there must be 12 carbon atoms according to the question. Hence we are supposed to have about a lot of hydrogen atoms bonded together. So what we are going to have is something like that. Okay. Then another carbon atom, another one. So you can draw it slowly by making sure that you know what you are doing. Right, so we have another one there. Then you blanch it like that. So you've seen that we have exactly what we wanted. 3, 1, another one is there, another one is there. So when you count together, it must give you exact number of carbon atoms that were there. You are just joining them, so they shouldn't be. So when you count, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is just a compressed structure. The body is too small. So this is a compressed structure of polybutene. Start. Butene reacts with steam in the presence of a catalyst to form a Claris compound. Name the compound formed. Now we know that an alkene reacting in the presence of water, or in short, and plus a catalyst there, they are forming a catalyst compound. Let me just do a quick example. If we have C2H4, that's ethene. So if ethene reacts with water, for example, we are going to have C2 with the carbon atom like that, the carbon atoms like that. Then we are going to have, we borrow one hydrogen there, we put there, we are going to have H5. Then we remain one here plus oxygen. So we are going to form ethanol, right? So ethene plus water forming ethanol. So if we have butene reacting with the water, we are saying butene is 4, then 8 plus water. That to give us, so we maintain this the 4 there. Then we borrow one hydrogen here, it becomes hydrogen 9. Then there's one hydrogen that remained here, then we go something like that. So this is butanol. So this is the name of the compound which they wanted. So the name of the compound is butanol. I was just showing you how we can come up with the formula of butanol and the reaction which they were talking about. So question E2 says, write a balanced chemical equation for the reaction between ethanoic acid and the compound named in E1 above. I indicate state symbols as well. So we know that we've got butanol as one of the compounds. And so when an alcohol and an ethanol, or for example, an alcohol and an acid, when they react, they form an ester. They undergo what we call esterification. Alright, so now we've got ethanol. Sorry, we've got butano. Reacting with the ethanoic acid. Now we don't have an ethanol, it's a liquid, right? Then an butano, sorry. Yeah, I keep on mentioning. So we continue. Ethanoic acid is like that. Now an acid is in an aqueous state. So they're going to form an ester. So let me. They're going to form an ester by the name. So we are going to get whatever is here combined there. Now when an acid and an alcohol they react, they release a water molecule, right? They release a water molecule. So they are going to form something like this. C4H9, then COO. So one hydrogen here will combine with the OH there to form what? Water. And water is a liquid, and this is an aqueous. So that's how the formula should be, and it's equally balanced. It's automatically balanced. So thank you for watching. See you in the next video.